All right, so I asked you guys to try this problem on your own before coming to this video. And so we're going to hit this pretty quickly. So this one is talking about strikeout totals for 32 games for a baseball player. And if we look at this, it said that the mean was 8.2. So this pitcher had approximately 8.2 strikeouts per game. But the standard deviation was 2.8. So the very first thing I did is I identified that mean. I plotted it right here. That's approximately 8.2. Notice for each of these, I go from 8 to 10. So this means this middle guy is a 9. Each chunk is half. So 8.5, 9, 9.5, 10, 10.5, 11, etc. In order to find my cutoffs, I took that 8.2 and I either added or subtracted 2.8. So that gave me my first chunk, which was 5.4 to 11. Applied the 5.4 and the 11 and counted up all of these. For here, we are going to include the ones that are on those borders. So this 11, those do fall within 2 standard deviations. They are the border. We are going to include them. So when I counted all of these points up, I got 23 of them. So we are able to say for this data set, 72% of the data fell within 1 standard deviation. So once again, this was 23 points right here. We then took our bins that we had, our cutoffs right here, and we added or subtracted that standard deviation to 2.8 again to expand. That's the purple lines here. And we can see that we added 4 more points and 3 more points here, bringing us up to a total of 30. So 30 of the 32 games fall within these 2 standard deviations, which is 94%. And then last but not least, we actually went all the way out. And notice here, sometimes the numbers don't make a lot of sense. And so here our cutoff was a negative number. Sometimes that's going to happen. We know that you can't have a negative amount of strikeouts, but we're just looking at the numbers here. And when we did this far out, we can see that yes, we did include those last 2. So this is what we mean when we're talking about percent of the data falling within a standard deviation, 2 standard deviations, or 3 standard deviations away from the mean. And when we're talking about that, we mean in both directions. So when I'm talking about 1 standard deviation away from the mean, I'm talking about if I subtract it and I add it, this whole chunk of data is data that is 1 standard deviation away from the mean. So from this, and we're going to kind of hit this next part really quickly, we're going to talk about what does this mean in the idea of a normal curve. Because if we go all the way back up, we said the normal curves are always symmetrical, and they are based off of these bins. So normal curves are really cool because they are symmetrical. That means, if I were to draw a line right here and fold this in half, it'd fall completely on itself. It's perfectly the same on either side. Well, the percent of data that falls into each of these categories is known as the empirical rule. The empirical rule tells us how much data falls in each of these categories for data that is normal. So normal and the empirical rule go together. So I said both of these were approximately normal. And notice that for the first one, we had 66% of data falling in the first bin. And for the second one, we had 72. Well, that's actually a really good approximation here because in reality, for the actual empirical rule, we're going to say that 68% of data falls within those first standard deviations on either side. Now, for the second one, we had 94 and 96, which once again is a really good because if you average those, you get the actual answer, which is 95. We say that 95 for actually normal data, 95% of your data is going to fall within those 2 standard deviations. And then last but not least is the third. For these data, it wasn't a huge data set, and so we actually had 100. For the empirical rule, that's slightly different. It's 99.7. So there's this 0.3% that often falls outside of the first standard deviations, or the first 3 standard deviations. So I have this question here. Do the above examples approximately follow the empirical rule? And therefore, are they normal? I'm going to have you guys answer that in your next check. And then we're going to come down and really talk about how can we put all of this onto a normal curve and do some other types of examples with it.